Hi, Marcus here from Evolution EMV again. We're going to pick up where we left off, but do a quick review first. To review, what is PIC? PIC is a database system comparable to SQL COBOL MUMPS, named after its primary progenitor, Dick Pick, although Don Nelson helped early on with its immediate predecessor, Girls. It was once a computer operating system all its own, like Windows, Linux, OS X, whatever, but now is a hosted database server process like any other process, like a mail server, web server, file server, etc. It's also often known as multi-value after one of its primary traits. One of them, I don't think really it's its most primary trait, but there you have it. Who uses PIC? Large and famous firms like Men's Warehouse, ADP, Caterpillar, Rainbird, and a bunch of others. Small businesses, probably around you, law firms, medical clinics, dry cleaners, trucking firms, and it's in every industry. Manufacturing, sales, marketing, aerospace engineering, finance, banking. In fact, one of the largest banking software providers owned JBase for some time. Transportation, distribution, genealogy, pharmaceuticals, insurance, just all kinds of places. Why use PIC? Well, because it's powerful. It's hardware agnostic architecture, multi-value data model, flat file system hierarchy, and mostly typeless basic programming language make for a really, really flat learning curve, and also a great deal of power. High performance and rapid application development. What could take a team of Windows programmers months to do, a single PIC programmer could do in weeks. It's flexible. As a hosted process that integrates on its host environment, it has full access to everything that the host has. So whatever the host can do, PIC can do. Makes it an excellent scripting language. I use it all the time. I do some interesting things on my own systems with it. It's affordable. I use an open source free version of it, and even the pay-for version is one of the most affordable versions of PIC there is. But PIC in general, studies have been done that show that even the most expensive PIC has a lower TCO over things like MySQL because of the greater load of programmers and development methodologies and management and structure and everything that surrounds those kinds of things. And I don't say this just for nothing. I've been in this industry a long time. I've worked for huge commercial shrink-wrap software vendors. You probably don't remember WordPerfect. I worked there for years. I worked for Daimler-Benz in Germany. Yes, I'm fluent in German. I've seen a lot of stuff. I know what's going on in the industry, and I know exactly what kind of programming goes on and what kinds of teams of things are being used. And I've got friends at Microsoft, I got friends at Google, I got friends at LinkedIn. I'm pretty well connected, so I know what I'm talking about. So how do you use PIC if you decide you want to use it? Well, the first thing is you have to choose your host. And that's going to be AIX, HPUX, BSD, which is really Apple, and Linux. But let's be serious. Just use Linux. Come on. Unix, what's called Unix these days, is fairly pricey, comes on expensive systems, and isn't really as well maintained as anything like Linux GNU. Apple's a non-player anymore. They used to be with AUX. Windows, let's face it, just has no business anywhere in your server room. Maybe as a desktop server, even that's debatable. And every firm that has plenty of experience and plenty of brain power, brain trust, they know this. And they've usually learned the hard way, and they don't forget the lesson. Windows doesn't belong in the server room. So learn from them. 90% of the world's supercomputers run a Unix-like operating system for a reason. 90% of the entire world's phone, tablets, phablets, fondled slabs, whatever you call them, they run a Unix-like operating system. Microsoft has even become one of the most prolific contributors to the Linux project. In fact, a number of industry pundits are speculating whether Microsoft may give up on Windows and just become another distribution of Linux, focusing rather on services and their productivity software, Office, and their online stuff, their Office 360. If you're crazy enough to go that way. Maybe they know something you don't, is the point. So keep Windows on your terminals, your desktops, your laptops, if that. I don't use it. I don't like it. I only ever have to use Windows because of clients who have rare applications that only run on Windows, and I have to use it. And even then, I keep it confined to a virtual machine because I really just don't like it. Then you have to choose your flavor. And you have a number of options here, and they all have their strengths and weaknesses. Rocket Software's D3 used to be Dick Pick's D3. It was his last project, last company that he personally was involved in. And as such, it's considered the reference, the original, the standard, the vanilla. But it's somewhat dated. My personal experience with them is the documentation isn't always up to date. They'll add features you don't know anything about, or options to features you never hear about it. And sometimes getting that information is like pulling teeth. There are a number of good resources, but of course you always want to be that resource, right? And if you can't find that information without pulling teeth or bribing somebody, what good is that to you? Rocket Software's Universe. Universe somehow wound up being the default player. Prime somehow evolved into Universe. Prime was one of the big PIC vendors that Dick Pick was somewhat involved with, and they now hold like 60% of the PIC market. And then there's Rocket Software. Rocket seems to be going around trying to buy up all of the multi-value or PIC flavors, so they can become the PIC vendor. But there's Unidata. Unidata is like the Cadillac of PICs. It's high performance, has amazing features, things that don't work in Universe, which are few, admittedly few. Like the calc feature. I like the calc feature. If only the calc feature worked. Last time I tried it, it didn't. In Unidata, it's the French braces, the curly braces, that allow you to call dictionary items as subroutines or functions. I think that's fantastic. It actually works in Unidata. It has very tight integration with a GUI called System Builder, or now SBXA. JBase was recently voted the best PIC. I don't know how I feel about that. There are things about JBase I really like, and when it first came out I loved it. I thought it was fantastic. But now I have OpenQM. ZoomAssist doesn't really own it. They're like the exclusive distributorship of it. Ladybridge makes it over in England. JBase and OpenQM, by the way, both born over in England in the early 90s. They're kind of contemporaries of Java. Java touted the write once, run everywhere. That was originally a PIC thing, because there were so many PIC vendors, so many flavors of PIC, you could write your application and run it anywhere. There's OnGroups Onware, which is really PIC being emulated on Oracle, SQL, etc. InterSystems Cache, which believes that they are the highest performance PIC there is. For file access, that may be true. It's actually another emulated version of PIC. It runs on another system that kind of was a contemporary of PIC called Mumps. Shows how well Mumps did, that they're emulating PIC. But it does distribute well across multiple CPUs and boxes and things. Then there's Revelations Open Insight. It's Windows only, but it can access Unix-based database servers on the back end, like Universe. And it has an integrated web access front end, which I think is a brilliant move. There are many things I like about Open Insight. I just wish they had a purely Linux version. And VIA Systems Univision may not actually be around anymore, but the website is more or less still there. I've been trying to contact them, see if I can get a version. There have been open source versions like Maverick. There's one or two others. PIC is just out there, and it's in so many different versions. Then you choose your front end or your emulator. This is how you're going to access the PIC server, because it is a server. And just like Outlook would connect to an Exchange server on the back end, or your web browser connects to the web server on the back end, you need a front end to connect to your database server or your PIC server. And which, by the way, would also connect you to the command line interface on whatever server it runs on. So there's Accuterm, which is probably the most popular choice, because it gives you terminal emulation for all of the most common terminals from back in the day. And personally, my favorite is VT320 for a few different reasons. But it only runs on Windows clients. So whenever I want to use Accuterm, I have to bring up my Windows virtual machine and use it that way. But most of the clients I've ever had use Accuterm. Or they let me use Accuterm if they don't have it. They don't have any qualms with me installing that. Then there's System Builder, or now SBXA. It works with most of the flavors, but it's really at home on Unidata. One of the advantages is that it has a GUI, that's a character user interface, kind of like the old DOS applications. But it's only 80 by 24, or 132, which is really like nothing. And then you have the GUI, the full GUI, but that's only on Windows clients. So you could technically, for example, connect to a system builder system using something generic like PuTTY or Xterm, and the GUI would work through that interface just fine, but the GUI won't. You have to have their client running on a Windows machine to get the full GUI. And then you have something like PuTTY. It's an SSH client for Windows. It offers full X forwarding when an X server is also installed, and that's an interesting feature. It's a fun feature. I like it a lot. It can add some cool GUI features without going full GUI, and it doesn't much matter whether you have Windows or Linux or Apple on the front end. It'll still work. Xterm was the X Window System standard terminal emulator back when GUIs first started to be created for Unix machines. Quite old, quite standard. Most other things emulate it. And it itself emulates something like, I think, a VT220. That's a DEC VT220 terminal. So any commands that work for it will work for this. And if you want to know the full list of commands, they're available online. You can also set up Accuterm to emulate it. Unlike, say, the Windows command prompt, that's like, what is it, a VT102 or something, and it's a kind of a hybrid at that. Then you have the Gterm, Mate terminal, Mac terminal. They're all very similar. They all emulate Xterm, and the links are there. Then you choose your development tools. You have System Builder's SBXA, and it can run as a GUI on the host or as a GUI on Windows-only client PC. Binary Star's Nucleus, again, runs as a GUI on the host. I don't know if it's limited to 80 by 24 like the others. Let's take a pause here. Okay, let's see if I can get this running again. Accuterm's WED or JED, the GUI editor, there's no GUI with Accuterm. It's roll your own or use their GUI. But at least with WED, you get a Windows editor to replace ed with, and that alone adds huge amounts of power to PIC. I use Nano, I'll show you that too. Eclipse has been used, but that's kind of a big endeavor, getting all of that to work together. And it's mostly for management types and non-PIC programmers who feel like PIC must be shoehorned into their world and fit their paradigms. Or you can roll your own, and I do, and I have, and I've written an entire GUI for PIC a couple of decades ago. Maybe we can resurrect that during these classes. If you remember the old original Apple, it looked kind of like that. So now we're going to get past the last episode, and now we're into the PIC file system. The PIC file system is probably really the heart of it all. Like I said before, Windows, Microsoft tried to come up with WinFS, which was really just the PIC file system on Windows or something. I'm not exactly sure what they were doing. I don't know why the project failed and it got pulled. I think maybe they were trying to put Windows inside of PIC, which is not going to work, as sort of a reversal of the idea of the way other PIC vendors do it, where they put PIC on Windows. What I mean by that is they create a container file, which is like a tar file or a zip file, and they can contain all the data in there and do their data positioning and location, hash files, all that kind of stuff, kind of in spite of Windows instead of with it. The same is true on Linux. But when they try to reverse it and do the other way around, take a PIC file system and then add in all the kinds of stuff that Windows does, I think that's where they shot themselves in the foot. But it's just my guess. I don't know. It would have been nice to see. But the fact is, we've got plenty of flavors of PIC that run on Windows. Every version of PIC there is runs on Windows. There's no flavor of PIC that doesn't have a Windows version that I'm aware of. OpenQM used to even have a smartphone version. It ran on Windows Phone. Kind of crazy. But it's hardware agnostic. You don't have things like drive letters. Like here, let me go over to Windows and show you what I mean. You all know this. You've seen the command. You've got, first you have to choose what drive you want to be on. You log over to that drive. Which ones have I got here? I've got a D. I've got a D. You almost have to shoot in the dark or know what they are. Go back to C. And you don't have any of that on PIC. That's too much hardware interaction there. But there is an analogy to it. Not having to worry about the hardware kind of makes it much easier to work on and to program on. One of the things, for example, in Windows is, notice the directory listing at the top there. Dear, whenever you do a directory listing, what does it always end up with? How much free space you have. That's very important. I mean, you've got all the directories, you've got everything in your face here. And that's sometimes just too much information. You certainly don't really want to be worrying about the amount of available disk space every time you look in a file. That's kind of a secondary consideration. So, in fact, let's switch over to my virtual terminal. And I'll just look there real quick, and then we'll look at the recording later to see if that kept the recording going or stopped it. I'm kind of curious to see. So, it's very flat, unlike other file systems where the hierarchy is practically unlimited. You can put folders within folders within folders. You can't do that on PIC. You only get a certain number of folders, so to speak, or the analog thereof, and that's it. And having fewer items on the menu to choose from at any restaurant very often makes it better. I mean, just look at In-N-Out Burger, right? Very simple menu, and look how hugely popular it is. People don't go in there and think, what do I want? You know, even if they get one of the so-called secret items off the menu, a 4x4 or whatever. So then there's the tipping point, and all file systems have this. Nobody really talks about it much. I think it's rather crucial because it's the dividing line between where the path to the data ends and where the actual data that you work with begins. So on a PIC system, you've got the system dictionary, and you can have multiple systems on a machine, but that's rarely done. Only in the case of, let's say you get a big IBM ZOS system and you're hosting like half a dozen or a dozen different systems on there because you've virtualized all your systems onto that one big piece of iron. So within a system, you have multiple accounts or master dictionaries. When you're looking at it from the system dictionary perspective, those are called accounts. When you're inside the account, you call it the master dictionary. Then within the master dictionary or the account, you can have any number of file dictionaries. So that's 1, 2, 3 levels down. Now, within a file dictionary, you can actually have multiple data portions. So technically, there is that fourth level. It's not always used. It can actually confuse some people. It's actually a very powerful thing. It's kind of like the dividing line between your typical code jockey, PIC programmer, and a real system designer, because when you know what you're doing with data portions, that's when you really create some powerful systems that have some clever features. We'll get into that later. Then comes the tipping point. Now you get into the actual data. Now there's sort of an ambiguous gray area here in PIC. I just want to mention it because you may hear it mentioned. It was certainly a big deal earlier on, and that is that one of the strengths of PIC is that it was adapted. The paradigm, the user-facing paradigm, was adapted to the real world. It was designed to work the way people work, hence the English language, query language, and the idea of nouns being data and verbs being programs. But it's also tuned to the hardware underneath. So when you read a record, the system will show you a record. But when it reads that record, it actually reads an entire group. And those groups, the PIC system administrator would tune his system, just like a Unix system administrator does, so that the group size and the hard drive's cluster size matched. Because, for example, and I'm not always keeping up on the technology, but in the early days you had two 512-byte sectors on a DOS hard drive. That equaled a cluster. Why clusters, I'm not sure, because every time it read, I know that it read a sector, but maybe it read an entire cluster. I can't remember for sure. Whichever the case was, you had to tune your PIC to match that. That meant your PIC frame size had to match the sector or cluster size of your hard drive, and that's when you got the maximum performance. It was optimized, and reading data off the hard drive was like the core of the whole thing back then. But like I said last time, nowadays these big systems, they read the entire hard drive. They call it demand paging. What it is memory swapping, page swapping. It reads the entire database file into RAM and works on it there, so disk access is kind of like a moot point at this point. Anyway, within the data items, and the data items are defined by ASCII 255. PIC uses these extended ASCII characters a bit differently as of the time back in, 1983 when PIC first moved over to the PC architecture. It had the extended ASCII character set to work with. Things were done differently in the early days. They were Unicode, they were on Unix machines. So now they're using ASCII characters at the high end of the table and working backwards in order to delineate the data. So ASCII 255 separates the data records within the group. You as a user, you as a programmer, unless you drop down to the level where you're actually meddling with the groups themselves and the forward and the backward links and all that, you will never see this ASCII 255. The system hides that from you, virtualizes it, abstracts it, completely. But you will see the next one. The next one is the attribute. That's PIC parlance. And what that is a row, a line, a field in any other kind of Windows or Unix or Mac file. And it is delineated not by carriage return or line feed, or both in the case of DOS. It's delineated by ASCII 254, or what is in PIC called an attribute mark. Under an attribute, attributes can be subdivided into values, hence the name multi-value. You can have multiple values within every attribute. On other systems that'd be called a subfield, which is sort of an arcane subject on them, but it's an everyday business on PIC. And they are delineated by ASCII 253, or what's called a value mark. These can be further subdivided into subvalues, or ASCII 252. On other systems, you'd call this a subfield, and like nobody does that. And within the PIC world, there is something that has become rather arcane. Almost nobody does this, but you can still find documentation on it. That is the text value, or the term, or the word, and it's delineated by ASCII 251. I've never seen that used by anyone. So, an example of a real-world PIC file system. You got to name your system. I've seen people name systems after planets, after major streets in the town they live in, after major cities in the state they live in, things like that. We'll just call ours Aardvark. That's the name of our system. And within Aardvark are going to be accounts. Now, traditionally, on a PIC system, you divide up the accounts. Remember, I analogized that to the drive letters on a Windows or DOS system. These accounts, and I'm sure I've seen it so many places. The finance department gets drive F. The IT department gets drive I. The C-suite gets drive Z, or something like that. And every department has their own node on the network that gets mapped to them, that they get access to. Well, it's kind of like how PIC used to be done. So you had the system divided up into the different departments. So we'd have production, finance, legal, HR, accounts receivable, accounts payable, things like that. And within those accounts, you would log on to, by the way, when you log on to the system, you don't log on to the system. Only system administrators log on to the system. Every user, and this is in the days before individual user accounts, you logged on to whatever account you worked in. If you were in HR, you logged into the HR account. If you were in warehouse or the shop floor, you logged into that account. You didn't have individual user accounts. Now, within each of those accounts, you'd have the different database files that would be pertinent to the work you did. In production, you might have customers, inventory, and vendors. In finance, you might have client accounts, orders, and others. In legal, you might have firms, cases, and benches, or courtrooms, things like that. But the fact is, nobody really works like that. Nobody ever really did. And remember, I told you that PIC was designed to match the real world, to work the way we work. Well, in a great degree it was. In this particular aspect, I don't think they really thought it through too well, because the fact is, this is how we really work. But it still works perfectly for this. And that is that we divide up the accounts according to the major applications on it. So, for example, I've installed Accuterm on my account. It's a QM account. It's a QM system. So Accuterm creates its own account. And I can use Accuterm from any of the other accounts, but it has its own account. This makes it very portable. If I want to copy it anywhere, I can just save that entire account. It gets all the files, all the data, everything's there. I have my ACE account, my AT2K252B, that's an older version of Accuterm, has its own account, and all these others. There are major applications that I've worked with in the past. That's the way a system is really typically divided. And the database files will be under those. The dictionaries, they're analogous to any other file system's folders or directories. And like folders, they can contain regular items, any data file that you might work with, and other folders. So you can have folders within folders. Let's just show you, highlight what I'm talking about. So I've got my home directory here. We'll go here, home directory, bypass the desktop, and look at all these directories I have. So I have desktop, and I have stuff, and I have work, and I have, let's see, what have we got here? I've got my system, and I've got my scripts. See how deep the path is getting already? And I could keep going. In fact, one of the exercises we went through in computer science class way back when was, back when we had these 720K floppies, we had to make some folders. We made A through Z. And then within each one of those, we made more folders, A through Z. So we had 26 times 26. Well, you didn't even get through, I think, the second, certainly not the third level, and you had filled up your floppy with nothing but folders, with no other data on it. So you can have all these floppy folders within folders, but you can also have regular file items in there, so you can have a mixture of both. And you will see folders within folders right up until the tipping point. You never open up a text file or a spreadsheet and see other folders inside it, right? That just doesn't happen, because the file system ends where the data begins. That's what I call the tipping point. That's why I call it that. Okay, and on hierarchical systems, it's flexible. As I was saying, you can just have ad infinitum folders, but on a PIC system, you're limited to just the four. You have your system, the account, the file, and the data. Once you get past this point, you're no longer talking about the path to the data, you're talking about the data. So to compare them, on a PIC multi-value system and on a hierarchical system. So you've got your system, which would be equivalent to the machine, the account, which would be roughly analogous to a drive letter, a dictionary portion of a file, which is going to be a folder on a hierarchical system, and the data portion is going to be another folder. And then comes the tipping point. Then you have the actual records, which on a hierarchical system will be the file. And within the record, you're going to have the attribute, which would be a row or a line on a hierarchical system. Within the attributes, you have values, which will be the columns. And yes, I know that a spreadsheet technically would be a table, which would account for a database file in a PIC system. I'm going for a different analogy here. You'll see the logic in a minute, I hope. So within the values, you have subvalues, and on the Windows or Apple or whatever, Linux, you'd have the subfield. And that's really the limit of it. And the parallels, keep this table. You may want it. So there's more to the story than that, though, and that is that file dictionaries can exist with no data partitions. So let's show you this. So here's something that PIC does that almost nothing else does. So where am I at? Host name. I'm on my server, and who will tell me which account I'm in. I'm in my EMV account. So I have in my master dictionary, I'm in the EMV account on my QM system, and so I have a master dictionary. It's always going to be MD or VOC. Okay. Some PIC systems use MD, some use VOC for the vocabulary. The fact is, you can create, if you have an MD, you can create an item called VOC if you're used to typing VOC. And if you have a VOC, you can create an item called MD. So here, let me show you that. So TMD, MD. So this one, by nature, is called VOC. But I'm used to MD, so I created an item in VOC called MD, and it points back to the VOC. This points to the dictionary. There is no data portion. It's a Q pointer. It's a reflexive pointer, points back to itself. So I can list MD, and I can list voc. Same thing. So I also have a pointer to my EMV file for evolution MV. Now if I list EMV, I'm going to get an error, file not found. Well, remember what I told you. When you do not specify, PIC assumes that you mean a data portion that has the same name as the dictionary portion. Because a dictionary of any file, your master dictionary points to the dictionary portions of any database file you have. The dictionary portions will then point to the data portions that you have. And that's what you're seeing here. Here are all my data portions. Okay? That's my dictionary portion. And this is a summary of the names. That's just how QM does it. So if you look in my list of data portions, EMV is not among them. I could just as well have said list EMV, comma, EMV. And by the way, the comma to PIC is kind of like the backslash is to Windows or the forward slash is to Unix. That's a comma. Still not found. Because the two statements, list EMV and list EMV, comma, EMV, they're equivalent. There is no data portion called EMV. But there is one called dev, list EMV, comma, dev. Aha, now we've got something. And I've got EMV lib. I've got EMV bin. I've got EMV VBA. I've got EMV HLP. See, where other applications create their own accounts, I create multiple data partitions because for the most part they can share the dictionary, and that's what the benefit. One of the benefits of having multiple data partitions under one dictionary is the dictionary is common across all of them. So like I was saying, the dictionary, CT, MD, voc, and MD. Now the voc one points to the actual system voc, but the one called MD points to voc. They're all just pointers. There's no data partition. The same thing is true of CTMD. Let's see, have I created one here? Pointer file? I have. Look at that. Notice that these are both the same. If I hold down the control key, I can block it like this. The dict and the data portion are the same thing. That's one way of fooling it. What it essentially says is the save lists file, there is no data portion. So you could say list dict pointer file and then list pointer file. Let's try list only. And then list only dict. See? Same thing. That pointer file and the @id are the same thing. So you're looking at the same data one way or the other. So if I select EMV bin and then save list test, now notice there's no test up here. There's junk, bin, and Mars. So we save list test and then we list dict pointer file. Now there's a test. And list only pointer file, same thing, same data. It went to the same place because they both point to the same thing. Now, that just illustrated the fact that you don't have to have a data partition. You can have just the dictionary partition with no data underneath, and it becomes its own little one-dimensional database. So, but file dictionaries can contain multiple data partitions, and I showed you that where I've got all the different data partitions underneath EMV. There's reasons for this. I have my reasons for doing it. One is I find it makes it more logical, more self-contained. If I have to work in one account, where everybody works, all the developers work. Then I can create a single file name. It doesn't collide with anybody else. I don't have files all over the place. You usually wind up hearing from a system administrator wanting to know why all of a sudden you've got a dozen files added to the backup or the list of files. I've just created one file, and that's kind of standard practice for any programmer anywhere you're going to create a file. I create all the partitions I want underneath it. That doesn't seem to rock anybody's world. Doing so is not very common, though, and kind of adds some obscurity, which is a kind of cheap security. People tend not to look for those kinds of things. Like I said, I can squeak past a lot of system administrators. I don't upset them. I don't have to get a lot of approval by creating just one file with multiple data partitions. But you have to bear that in mind too when you're looking at other people's work. Don't assume that they've only got one data partition underneath. There could be multiple. You've got to check for it. There are ways to do that, and I'll show you. Still more, any column within your database, any attribute in PIC parlance, in a table or a file, may have any number of dictionary items associated with it, or none at all. So let me show you how that works. So we're going to log to another account here. This, by the way, is just a utility I wrote to make sure that PIC understands exactly how big my screen really is, because it's not a given. You have to tell it. Typically it's done with a term command. I hate working in 80 by 24, and I hate working on green on black. I like the old paper, what they used to call the paper white monitors. So we have a file here, list SO. Nope. Log to HPI. Again, my screen dimensions. There we go. We've got a database file here. And this is the service orders. And we can copy one to the terminal. So, by the way, I'm going to try to always remember to point out to you where PICs are different, where PICs are similar. OpenQM by default is a prime flavor, which means you would do something like this. List SO with ID like and dot dot dot, and we'll say 133 dot dot dot. This is what we call truncation, and this on Windows or DOS would be equivalent to the star, the asterisk. Okay, it's dot 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 or ellipsis on those systems. But QM, this is one of the things I love about it, easily configurable. Just flip a switch, and now it uses, instead of like, you use equal, or nothing at all actually. You can just leave that out, it doesn't care. 133. Now you got left truncation and right truncation. And you can use those together kind of cleverly. The ellipsis, it gets a bit dicier, but these left and right brackets, they're very powerful. And we have to use the proper name. It's add ID on this system. So I've got a bunch of them with 133 in there. See how that worked? And it'll be anywhere in there as long as there's a 133. Right here, it's right here, unlike the others up here. Or you could say something like, I want all of those that absolutely begin with 001, 0013, let's say. And that's all we've got, those that begin with 0013. Okay? But there's more to it than that. Now, all PICs will have a default dictionary name. What we're going to deal with now is dictionaries. If you don't know what the dictionary names are, it depends on what system you're on. If you're on JBase or D3, it'll be star A1, star A2, star A3. I think those are the only two that do that. On QM, Unidata, Universe, it's F1, F2, F3, F4, F5. But you got to actually get the F in there. Now that is a default view on the data. It just gives us raw data. We don't know what any of this means. You look at that and think, oh, well, that's Texas, but wait a minute, that's not a state. What could that possibly mean? Oh, what is this? Is this a price? What's that, a zip code? What are these things? We don't know. Well, that's what the dictionaries do. The dictionaries define and describe the data for us. Now, they're not enforcers. You can put any data you want in there. But to give you an idea of what a dictionary is really all about, let's go to a spreadsheet. So let's say we've got a table full of information here. In this column, we want to have money, currency. 2 decimal places, $, turns red if it goes negative. Okay, so anything I put in here, 50, 75, 132, it's all money. Okay, 1523, it knows how to format it because let's say hidden underneath this D is the code that tells the rest of the column what's supposed to be in there. This one we want to have as a date. So it's going to be a date with any number of day digits, 2-year digits, and 4-year date. Do we have any others we might want to use instead? We could custom create one, but I don't want to take the time for that right now. So we'll just go with that one. So any numbers I put in here, it's going to turn them into a date of some sort. Lovely dates, huh? Interesting dates. And this one is defined clearly as a time with that format. I didn't like that. So I don't know what gives Windows or Excel a proper date code in there. But again, let's assume for a minute that what defines this is hidden under here. It's hidden under the letter, and we call those our dictionaries. That's kind of how pick works. So we want to find out what dictionaries we have available to us. Now, a couple of ways we can do this. One is you list the dict of the file. And remember, on our flavor of pick, we have to put an asterisk. JBase and OpenQM do that. I think they're the only two that require that. If you were to do this on, say, D3, it would literally show you the record named asterisk star. And you probably wouldn't have one, and you'd wonder what's going on. It would say no records. But if we leave it off here, look at that. If I put it on, I get the same thing. Nope. I've got this account set up in a different flavor. And you can do that too. Okay, so there are my dictionary items. Let me check. Okay. So what I want to do is I want to sort dict SO, and notice that in attribute 1, this is field number 1, this is the name, and this is what we called F1. We've got a lot of strange things here. Dictionary items are defined typically as A, S, I, and X. There are a couple of others that's more involved. The A is the attribute defining item. It's not enforced, but it's a good practice that you only ever have one attribute defining item for a field. And that way you can look them up quickly by the A's, and you can get a good overview of what's supposed to be in the database. And typically it will be unadorned. You won't have any translates or formats or anything else. It'll just be the name of the field and, say, the width. So, what account are we in? The HPI. Okay. So, we want to see what's in there. So we're going to say sort only dict SO by the field number, which should be here. So it's going to be F2 by attribute type, which will be F1 by add ID, which is the name, and that's just going to give us a 3-level sort on it. And then we're going to show F1, F2, F3, F4, F5, F. That's how you go wrong. F6, F7, F8, F9, F10, F11, F12. See, I love working with a wide screen. And what do we get? we get a whole bunch of stuff, not all of which actually appears to be dictionary items. Remember I told you about the different kinds of dictionary items? You've got A, S, I, and X. X means I'm not a dictionary. Well, pretty much anything except A, S, or I is going to mean I'm not a dictionary. Someone wrote an application that put these things in here. Why they wanted to have them there, don't know, don't care. You see a lot of strange things on client sites. Don't ask questions, just get the work done. So, what we really want is just the attribute defining items, because like I said, in a good disciplined shop, those are going to be the ones that tell you what the data really is. So we're going to modify this a bit and say sort only dic SO with F1 equal to A, then sorting by F2, F1, and add ID. Okay, now we got the attribute defining items. Well, you can tell right away this shop does not exercise good discipline. These are translates. That means they're virtual or calculated fields. They go and get their data actually from the same database, but out of a different field. So these are not attribute defining items. These should be synonyms. Anything with a translate here, it's got to be a synonym. And pretty much anything with any fancy formatting, mathematical calculations, anything, it's got to be a synonym. You want to know what that field really is, and we're not getting that here. So let's keep looking, and look, it's also attribute 0. That's kind of a giveaway. Whenever you have attribute 0 pointed to, what it's doing is it's taking the ID and it's going over to, in this case, it's tacking the ID onto that number. All kinds of things. So we take the quantity out dictionary, whatever it's producing, and we multiply it by the price. So this is a mathematical formula. Again, it's a calculated field. It doesn't really have a field. It's a virtual field. So what else would it point to except 0? You could point it literally to anything. It wouldn't matter. But 0 is at least a good practice when you've got a virtual field or a calculated field. So you can filter those out easily. But now we get down to the meat of it. So attribute 1, attribute defining items. We've got 4 of them, all identical except for their names. That's strange, but okay. Now here's a problem we've got. 10 doesn't come after 1, except when you're left aligning. We want to see attribute 2 and 3 and 4. Well, how are we going to do that? The way we're going to do that is, now here's a curiosity about pick. The dictionaries work in backwards order. So if we're listing the data in SO, and I can do list SO, comma, SO, right? Or maybe not. I've got to sort out a few things on the system, because I could list EMV dev, and by default, SO's native dictionary item should be SO, or native data partition should be called SO. Well, that's interesting. Must have something to do with the flavor I've installed here. So anyway, the dictionary involved here, when we list SO, let's do a, that's what we want right here. The very first one, if we do a CT, out of there, CT SO star. Look at that. About the first 30 fields are pretty heavily populated. We'll almost never get blanks except on 3, 17, 20, 22, and they're probably true all the way down here. So we'll just say the first 30 fields we're likely to get something that's worth looking at. So we do our list of the dictionary, list only dict, and attribute 1 is cust. So we've written it here, we've stored that. We can say list SO cust. That's kind of arduous going through that all the time. But trust me, you're going to be looking at your dictionary items a lot when you're working with pick. It's sort of a self-documenting system. If you want to know what the data is, you don't have to pull out a document and look it up. You can just look in the dictionary item. And if the dictionary item isn't there, being a savvy programmer, you study the data a little bit, see what kind of data is in there, and you create the appropriate dictionary item. Because as I said, any file may have multiple dictionaries for a particular attribute, or it may have none. That's why you list SOF1 if you don't know what it is, and list the dict and see which ones are available for that attribute. We've got 4. We could use any one of those 4. They're all the same. Just take the shorter one. So we're using cust. So list SOF1 cust, and you'll see that they're the same thing. See that? Except that F1 is the default that you use if you don't know or there isn't one. So let's assume we looked up a bunch of others. Oh no, we want to cover that ground. I told you the dictionaries work reverse. What does that mean? That means if I list let's copy the terminal, dict SOATTR. There's none. But I can list SOATTR. Ah, where'd that come from? What is that? That is because in the master dictionary, copy the terminal, master dictionary, or voc, remember we could use voc, ATTR. Now this is a dictionary item I created. And that's what the dictionary has in it. The rest of it you can ignore. That's what happens. You use it the first time, it compiles it, it fills that data in so the system can grab it faster next time. ATTR, attribute. Why did I create that? Because there is no ATTR, CT, dict, SO, ATTR. There's none there. It's because I want to list dict not dirt, SO, F2. But I don't want it to sort that way. Let's go back to our sort command. There. See how we're sorting it? We're sorting it by the attribute number, F2, but we get a left-align sort. All of the default dictionary items sort left by default. If you don't want to use the default dictionary item, then you have to create your own dictionary item. But the problem is a dictionary item cannot work on itself. That is to say, I can't create dict SOATTR and put all that information in there, how to list this field to. It won't work on itself. So you have to go to the higher dictionary item, which in this case is the MD ATTR. I put it there. Now I can list dict SOATTR, and I get that attribute number. Can't see it because we've got a bunch of non-dictionaries mixing in there. So what we do is go back to our sort command, and instead of listing F2, and there's a difference between sorting by F2 and listing by F2. So we're going to sort by ATTR, and we're going to list ATTR. And look what we get now. Notice that the numbers are all on the right, and it's sorted by the right. It's sorted the way the dictionary says to sort it. And look what we get. We get attribute 1, all grouped together, and then attribute 2, all grouped together. Now those are all the different dictionary items that are available to address attribute 2 by. And we're going to take QTY because it's simple. When we're looking for attribute defining items, we're looking for things that are going to be blank in here. No translates, no fancy formatting. We're just looking for pretty much raw data, because that'll tell us what the field is supposed to be. So I've already got a bunch. We've got quantity, dest, status, stamp. So, by the way, we don't want to have to keep remembering this command, right? There's a way to do that. We're going to do this. We're going to create a paragraph, wed MD in the master dictionary again, and we're going to call DSO for dictSO. Look at that, the Windows editor that comes with Accuterm. It's a wonderful thing. So we're sorting dictSO with F1 equal to A, sorting by F2 Oh no, sorting by attribute number. I already set it up. Look at that. Sorting by attribute number and listing attribute number. And we say that. Now, all we ever have to do, we don't have to remember this. All we have to remember is this. Isn't that nice? So anytime I want to refresh my memory as to what's in the dictionary there, all I have to do is type DSO. So let's say I've done that. Now I've got everything I want, and I've decided that these are the dictionary items I want to use. I'm going to list out a report. There we go. And we see a problem. Oh, we don't like this. We want to use a 2-digit year because we're going to add a whole bunch more fields on here that are going to extend the width beyond what we have. So we have to get compact. So we're going to shrink the width of stamp. So we're going to say wed dict so stamp, and we're going to shrink that by 2, 8 characters, and we're going to make it a 2-digit year. That's what this code means, is 2 digits / delineated date, left aligned, 8 characters wide. Like I said, you can forget all of that, don't need it. We'll even take it out and show you how that works. And this is the label that appears when you list it. Save that. Execute this again. Now look, we've got 2-digit years instead of 4-digit years, and it's 2 characters narrower, giving us more room over here. And we've got 3 decimal places for money, so maybe we don't want that. So we're going to post price. We're going to wed dict so post.price. We don't really need 3 digits for that, so we're going to reduce it to 9. And we're going to make it MD2 instead of MD3. That's make decimal. Okay, remember what we did to stamp? See, we deleted all of that after that because that's what the system compiles it to later on, and it put it back in. So we're going to take it out here, and that just forces a recompile. Now we list it again, and watch, you'll see these prices drop from 3 decimal places to 2, and price will shrink by 1 place. There we go. Saved a little bit more room. And that's what you can do with your dictionary items. So we've covered some simple output formatting codes like dates and decimal places. We've covered the creation of dictionary items. We even created a paragraph. Let me show you that paragraph again. That's wed MD To cover that again, what I had to do, unable to get med because it's MD, not med. PA, that stands for paragraph. You can put any number of commands after it. So you can create aliases is what you're doing. Anything that you would type at the command line you can put here, and then you can call it by the name that you gave it, and it works. So whenever I want to check the dictionary of this file, just type DSO or whatever other name you want to give it, and you'll get a reasonably readable listing of what's in the dictionary. So we covered creating the paragraphs. I did a review of that unbelievably loud and long first effort. I hope you'll all bear with me as I improve these videos over time. And they will disappear on occasion as new ones replace them that are hopefully done better. I've shown you AccuTerm, PuTTY. This is PuTTY. We jumped over to see if the Linux virtual terminal shows up on the recording. We drew analogies and parallels between the PIC file system and the Windows/Linux file system. And next time we're going to be covering some rudimentary programming, opening files, reading records, manipulating data, writing the data back again, including record locking, which is a core staple of any database system, any multi-user system. You have to have exclusive locks on data while you're changing it, and nobody else can hit that data or take that data away from you. That is crucial to any multi-user system. And so we're going to work on that next time. You'll write your first Hello World program, and you'll be proud PIC programmers. So that's all for now. This will be Marcus at Evolution MV signing off, and we'll see if I can get this thing to end properly. Where is it? Right there. Bye, y'all.